Problem on Anova two-factor without replication. The following data represents the hours per day by 4 different students on 3 different days. Test whether the study hours of the 4 students are same. Test if the study hours on different dates are same. So the two things we need to test. Data is given here. Days Monday, Tuesday, Wednesday. A, B, C, D are the students. And 2 hours, 3 hours, 4 hours, 5 hours, etc. Question says state the null and alternate hypothesis. Compute the critical value of F. Get the calculated value and determine whether to reject or fail to reject the null hypothesis. Let me put the data here. Same thing typed. HO, all students study the same average number of hours. Alternate, at least one student studies a different number of hours. It is, we have to go to data. Average study hours are the same across Monday, Tuesday, Wednesday. Alternate is at least one day has different study hours. These sort of things are done by Anova, analysis of variance. There are two factors here. Students are there where you have to go to. How do you do that? Simple. Excel has a tool, data analysis. Now, as we said earlier, it is two-factor without replication. If there is something about replication, we'll do a similar problem later on. But this is without replication. You say, okay. Now it will ask for where is the data. Now be careful. You have to include the entire data from here, A, B, C, D, including the row and the column, the row headings also here, Monday, Tuesday, Wednesday. That is the data. Labels are there because days A, B, C, D are labels. So I have to one, otherwise it will take that also as data, which has no meaning. Output, let me put in some other place. Already made once here. Output. Okay, I want to put it in data available or off from here. I hope that output range. So it says rows. Row stands for the days. The critical value is 42.3. F critical is 5.14. Sorry, the calculated is 42.3. Critical is 5.14. Calculated is more. Therefore, we reject the null hypothesis when it comes to the rows. And rows are the days. Or in this case, both. This is 19 is F value. And critical is 4.75. So this 19 is more than 4.75. So even that hypothesis, null hypothesis, rejected. Even if you don't want to compare these, the fact that it is 0.00029, which is less than 0.05. So if P is low, reject HO. If P is low, reject HO. So even looking at these two things also, we can say we reject hypothesis for both the rows as well as for the columns. It's a simpler method of doing things. How to do complicated methods, I taught you in the class. But in the examination for this purpose, this is what is expected using the data analysis ANOVA two-factor without replication. But be careful about selecting the data. The data has to be the entire thing. Like here it is B17 to B20, B17 including this thing to B20. Cancel that. So that's, we can write that this is rejected and therefore this is accepted. So at least one student studies a different number of hours and at least one day has a different study hours.